All right, we're going to continue on and try and finish up 4.1 here. Let's see what we can do here. Here we're talking about complementary and supplementary angles. Basically, two positive angles are complements if the sum of their measures is 90 degrees or pi over 2 radians. And two positive angles are supplements if the sum of their measures is 180 degrees or pi radians. So to find the complement and supplement, just basically subtract them either from 90 or 180, and that's pretty much going to be it. So let's take a look here. Actually, complementary angles, this kind of thing is actually can be very useful in things like physics. If you have a projectile fired at complementary angles, they're going to end up landing at the same place. So there is actually some nice little use for this, other than just, all right, let's see if they add up to 90. So there are some practical applications of this. So let's take a look here at the first one. It's 73 degrees, and basically what we have to figure out is what angle, we'll call it the complement, put a little C down below, will add to it to make it equal 90. And if you just do a little bit of algebra, subtract 73 from both sides, you should get that it is 17 degrees. And therefore the complement is 17 degrees. If we wanted to do the supplement, we do 73 degrees plus theta, and I'll put a little s for supplementary, what makes it equal 180. And you subtract 73 from both sides, and you just get that it's 107 degrees. So the supplement is 107 degrees for that angle. All right, so it's pretty much just doing that. I'm going to leave the last ones for you to try. And again, I'll probably throw them on the notes for you to look at and see if you need to. So let's continue on. Length of an arc of a circle. This is that arc length we were talking about back in the first video. The length of S, or the length S of the arc intercepted by a central angle with radian measure theta in a circle of radius r is given by the arc length S equals r times theta. And again, this is the same formula basically as before, but before we had it written as theta equals S over r, and we just multiplied both sides by r here to get our new version of it here. And still, do not use with degrees. This is only going to work in radians. All right, you don't get nice, neat little formulas like that with degrees, but it works out real nicely in radians. And so the length of S is just that little blue section right there, is this blue arc right there. And basically, like if you were walking around this track, it would be how far did you walk around, how far did you end up walking around your circular track, that whole distance. That's that arc length right there. So let's try some of this. Let's say, let's try this here. It says a circle has a radius of 18 inches. Find the length of the arc intercepted by a central angle with a measure of 210 degrees. Well, we don't really want to do this with the 210 degrees. What we would like to do is convert this over first into radians. So this formula works with radians. So what we want to do is say that theta equals 210 degrees, and we're going to convert that into radians. So we'll put pi radians on the top. That's what we're going to. And 180 degrees on the bottom. That's what we're getting rid of. We're getting rid of the degrees. So those will cancel, and you end up with 7 pi over 6 radians. All right, and that's our angle measurement right there. And then we can just simply use this relationship that the arc length equals r times theta. Here, our arc length was 18 inches, and our angle measurement is 7 pi over 6 radians. And that's going to then, we multiply this together, and we end up with, 18 divided by 6 is just 3, and 3 times 7 is 21. So we end up with 21 pi inches. You could plug that into a calculator if you wanted to get a little more exact, or I guess a little less exact if you wanted a decimal place, but 21 times 3, you're talking 63 point something inches for how far we went around the circle. And so that's the nice thing about, again, about once it's in radians, is it's very easy to calculate this. If you were trying to do this while it was in degrees, you'd have to find the circumference of the circle, take the fraction of the whole circumference that 210 degrees is, take that fraction, and figure out then what fraction that is of the full thing, and then that'll end up telling you the same thing. You didn't get in the 21 pi inches, but it would just be more trouble than this, and it would take you a few more lines to do it that way. Okay, so that's the basic way you want to approach these. Get your angle in radians and then do this. Now notice I dropped the radian unit. I had a radian unit right there, and it's just gone over here. Technically speaking, radians are not really a unit. They are actually, it's actually a ratio, like we talked about before. It's fractions of the full circumference you went. So technically it's a ratio, which means that we can kind of write it when we need it and kind of just get rid of it whenever we don't. And in this case, we don't need it anymore to tell us that we're looking at that ratio, because now we're just down to having an actual length. So 21 pi inches. All right, let's take a look at this next one. A circle has a radius of 25 inches, so radius of 25 inches, and the arc intercepted by the central angle is 7 inches, so 7 inches. That means that R equals 25 inches, and S equals 7 inches. All right, if we use our formula that S equals R theta, and we're trying to now find the measure of the central angle. So we're trying to find that central angle, that's theta, right? Find theta. We can go ahead and solve this for theta by dividing both sides by R, and you get theta equals S over R, and then we can plug these numbers in. S is 7 inches, R is 25 inches, and the inches cancel with the inches, and we're left with 7 over 25. And since this is an angle ratio, or the ratio of a circle, we can actually go ahead and add that radian unit back on there. Well, kind of a fake unit there, but there it is. It's 7 over 25 radians, so that we know we're talking about an angle measurement there. All right. So let's do one more example here. And basically for this one, we're going to find the distance between two cities on Earth. Now, you can't just draw a straight line like we think, because the surface of Earth is curved. And so you kind of have to go through what we're about to do right here in order to get that done. Okay? So let's take a look at this. The latitude of any location on Earth is the angle formed by two rays drawn from the center of Earth to the location and to the equator. The ray through the location is the initial ray. Use 3,960 miles as the radius of Earth. So let's take a look at this. Billings, Montana, latitude 45 degrees, 48 minutes north, is due north of Grand Junction, Colorado, latitude 39 degrees, 7 minutes north. How far are the cities apart? So remember, we are given that the radius of this circle that we're working on is 3,960 miles. Okay, so that's a given. That's given to us in the first part. And so we're looking over here at this little part of a circle, and we're going to try and find that little section of it right there. Okay, maybe do it in red. That little arc length right there. Okay, so let's get back to it here. We want to first convert both latitudes to fully into degrees. So let's convert both latitudes to degrees. Okay? So 45 degrees 48 minutes is going to equal 48 minutes is what fraction of a full 60? Well, if you think about it, this is 48 over 60 is essentially what we have there, which is going to be what, 4/5? Yeah. Yep, 4/5. And so we end up with 45 and 4/5 degrees, which we can make 45.8 degrees. And I use this conversion over here because earlier we said that there were 60 minutes in 1 degree. So anyway, moving on, the next part is 39 degrees 7 minutes, and that's going to be 39 and 7/60ths now, because that's 7 parts out of the 60 of degrees there. So 39 7/60ths. And that's going to be then what that is. I don't want to write that out in some decimal form. Now we want to convert both angles to radians. So now convert to radians. Okay? And we'll do that the same way as before here. We'll do 45.8 degrees, and we're going to multiply by pi radians because we want radians and we want to get rid of degrees, so 180 degrees on the bottom. Those will cancel, and we're going to get about 0.25444 pi radians. Now this is obviously just a rounded number, but you would want to keep the unrounded number in your calculator until you reach the end. All right, so store it or something like that, save it in a variable. Most calculators can do that, but keep that number where you can pull it back up there. And then the next one is 39 and 7/60ths degrees, and we're going to convert that. Again, 180 we're getting rid of, so we put it on the bottom. We want the radians, so we'll put those on top. And when you plug this in, you get about 0.217315 times pi radians. And again, you want to keep that unrounded as well. Keep unrounded in your calculator. All right, we don't want to end up having a rounding error because you never really want to round until you reach the end. And then we're going to use S equals R theta. Okay, and theta in this case is the amount of the angle that we went through right here. Can't get it to zoom in. So theta right here is the angle we went through between them, which means it's the difference between those two angles, because one of them has this angle and the other has this angle. And so the angle theta is just the difference between those two angles, that little bit right there. And so r theta in this case is just the difference between them. So where theta is the difference in angle between the two locations. Okay, and so we'll do this. And again, R we had up here was the 3,960 miles, so S equals 3,960 miles. And we're going to multiply that by the difference of our two angles, so 0.25444 pi radians minus 0.25444 217,315 times pi radians. And so you can just subtract those two numbers from each other. You don't even have to multiply the pi's in there, because you can pull the pi out and multiply all that together, do the subtraction, and you get about 461.9 miles, which I guess we can round off to, these are about equals to, we can round that off to 462 miles. And that's the distance between the two cities. Okay, that's it for section 4.1.